in section B, if it's only worth 1 mark, then this question should be quite straightforward. So they give you a function. K is a constant, only x is variable. So with different input, then we predicted the graph will be since 1 plus k is positive constant, so the x squared coefficient is positive, so it's upward sloping. Maybe it's like this. And then denotes the point 433. We have to prove that this line always passes through this point no matter what is k. So we consider when x is equal to 4, then fx is equal to 1 over 1 plus k. So extract common factor 33, and then we find that this part can be cancelled out. The result is 33. So therefore, we know that fx y equal to fx pass through that point. In part B, they say that there is another function related to f. Is from fx, and then we refactor it with respect to y asset. So refactor it, maybe it's like this. My drawing is not very good. It should be symmetric. And then move the translate upward by 4 units. So move it by 4 units. Let u be the vertex of the new graph. So we have point u here. And then we have to use the computing square. They restricted to use the computing square to find out the coordinates of u. Because it's not fixed, the shape of the graph depends on k. So our answer will be in terms of k here. And then you have two approaches. The first is you calculate what is gx first by some transformation method. And then the second method is you get the vertex from fx. Finally, you use this operation to find out the image of that vertex, which is u. So just computational skills. We are going to change fx into vertex form, but I think it's too trouble to copy down this factor. That's why I just focus what inside. We consider x squared plus 6k minus 2x and then plus 9k plus 25. Especially in complicated questions, always focus on a very small part that you want to change and then make your step easier. So computing square, this is 2 times something, x times something. To make it the same, what inside should be 3k minus 1. That's why what is missing is plus 3k minus 1 square. We have to subtract it immediately to avoid any value change. And then the first 3 terms will become something square, which is the first item plus the second item, 3k minus 1. And then right hand side is just handle this, prepare bracket, and then plus 9k plus 25. So this is x plus 3k minus 1 square, and then minus 9k squared, plus 9 plus 6, so plus 15k, plus 24. So go back to our question, fx is equal to Therefore, vertex of y equal to fx is when this bracket becomes 0, that means when x equal to negative 3k plus 1, then the y coordinates will become this term. But we should be more alert that this may be divisible, so we try to calculate in our draft 9k squared minus 15k minus 24, extract 3, and then this can be factorized. We may minus 8 and then plus 3, that means plus 1 here. So we find that this divided by k plus 1 then will be cancelled out. So our answer here, to simplify, the result is negative 9k and then plus 24. Y equal to fx, then the vertex is negative 3k plus 1 and then negative 9k plus 24. And then after some transformation, it may become like this, and then so this point u, therefore u is left hand side become right hand side, so this one x coordinate times negative 3k minus 1, and then still the same height. After that we move up by 4, so we just use the y coordinates plus 4 is negative 9k plus 28. In B2, we have to find k such that the area of circle passing through these 3 points is the least. In this question, maybe it's very confusing. That's why we try to draw the questions and also have some analysis first. Fx is depends on different value of k. It will give you different shape. But however, no matter what is k in part A, we already confirm that cancel out by the denominator and then it's passed through 433. So that means no matter what is the shape, it's passed through this point 433. The graph may be like this when k equal to 1. When k equal to 2, maybe it's like this. K equal to 3 it is like this. Or if k is some other value, it may be like this, no one know. For different shape, we have different vertex. That means u is not fixed. It depends on what is the suitable value of k that you want. And the fact here is ask you to choose a suitable k such that the circle is the least one. And then to consider this one, FOU, only fixed point here among these 3 points is F is fixed, O is also fixed, but U are not fixed yet, and you can choose a suitable one. That's why the graph we have original, we have 433 point F. If we ignore U and then we just try to draw a circle which pass through O and F with the least area, that means OF is our diameter, and then we just choose a suitable value of k such that U lie on this circle. This is our target. And what is the following implication is if these two fixed points form a diameter, U is a point on the circumference, then this should be right angle because of the reason angle in semicircle. And the coordinate, if this is right angle, the implication that means the slope OU times the slope UF is equal to negative 1. Then we can successfully find out the relation, that means the equation with k, so that we can solve the suitable k with this result. Mark down here first. So our target now is if the circle have the least area, then angle OUF equal to 90 degree. So the slope OU times the slope OF should equal to -1. So we start our calculation. All terms are divisible by 45, so this is 2k squared, and then plus 5k minus 3. Factorize our quadratic expressions. So we have 2k and then times positive 3k times -1. So k is equal 1 over 2 or k equal to -3. You should double check, is there any one of the solution we should reject it. They say that k is positive, so k can't be -3, that's why we reject it. Then that's why k is equal to 1 over 2 to fulfill this requirement. Now is the most difficult part. For any positive constant k, this graph passes through the same point G. This is talking about y equal to gx. If we are thinking about y equal to fx, there is also a point. No matter what is case, it's still passing through that point. So for y equal to fx, no matter what is k, it's still passing through this point. Maybe the graph is like this, depends on different value of k. And then they tell us that after translation or transformation, there is a similar point to f. That's why G is basically the image of f. You just translate this point, transform this point following this procedure, you get the coordinate of G. Reflect along the y-axis, that means it's -4, and then go up by 4. So this is -4, 37. We get this point G here. So G is -4, 37. We make good use of this sentence already. After that, they say that V is the vertex of the graph. The red line is y equal to gx. V is the vertex of the graph. I have no idea why they need to use another label, but we just refer to U here, no difference at all. Such that the area of the circle passing through F, O, V are the least. This sentence, again, O and F are fixed, and then V is depends on what value of K you choose. You can choose not every point, but you can choose most of the point on the coordinate plane. And then they just simply ask you to refer to this case 2. That means V is the situation. when k is equal to 1 over 2, the same as B2. So you have O, you have this point, and also you have V. Your key point is find out G. If you include G also, is that a concyclic? If we use the previous figure, that means they ask you that we already know a point G, negative 437. Is that G path is here, or here, or here? If point G lie on this circle that we already fixed it in B2, then that means they are concyclic. 4 points are concyclic. In reverse, if point G is not is outside or inside, that means they are not concyclic. Is what the question asking. If you understand what the question asking, then this is become much easier question. There are some approach you can achieve the same target. The first one, if you assume point G is on this circle, then this angle should be also 90 degrees. So by testing the slope OG and the slope GF, their product is that negative 1 or not, then you can make your decision. Or in other words, because you know that OF is the diameter of this least smallest circle, then you may find out the midpoint, which is the center, and also find out the radius. And then you find out equation of circle, you test whether this point lie on the graph. But of course, the first method is most straightforward. You just need to calculate the slope of OG while we have the coordinates already. So first, we write down our finding. You don't need to explain at all. You just simply write down G is negative 4 and 37. No step can be written down. Then we can consider the product of two slopes. Consider the slope OG times the slope GF is equal to 37 over the negative 4. And then GF, we just compare these 2 points. 37 minus 33, negative 4 minus 4. So this is obviously not equal to negative 1. That's why they are not concyclic. Therefore, angle FGO is not equal to 90 degrees. Therefore, the 4 points are not concyclic. We finished the question.